This is our calculus true response problem that I'm going to entitle the integral as a function. And what do I mean by integral as a function? Well, I'm going to start out by reading the problem. The graph of function f consists of the semicircle line segment shown in the figure. Define the area function a of x equals the integral with the lower limit of 0 to the upper limit x of ft dt for x is greater than or equal to 0, less than or equal to 18. And so this function f here is going to be equivalent, it's going to be the same as the first derivative of the function a. So what that's going to be is, in the case of problem part A, we have a of 6 is going to be equal to the integral from 0 to 6 of f of t dt. And what that's going to be is the area of this corner of a circle. And the area formula for area is pi r squared. So we have a quarter circle, so 1/4 pi, and the radius of the circle is 6. We have 6 squared, which equals 1/4 of 36. So that's going to be 9 pi. And as far as a of 18, I'm going to now hash that in here with, in red, overlapping. That's going to be the area of this semicircle and of this triangle here. Well, what that's going to be is 1/2 of the circle pi r squared, which is 36, plus the area of that triangle, which is 1/2, the base of the triangle, which is 6, and the height, which is 6. So a of 18 simplifies to 1/2 of 36, which is 18 pi, plus 1/2 of 36, which is 18. So that's what we have for part A. Part B, what is the average value? B, average value equals 1 over b minus a times the integral of from a to b of f of x dx. Well, in this case, average value that we're looking for this function from 0 to 18 is going to be 1 over 18, and then times this total integral from 0 to 18. So that's going to be, as calculated in part A, 18 pi plus 18. Now, part C, write the equation of the line tangent to the graph of A at x equals 6. Well, what we need to find the equation of a line are two things: a point and a slope. Well, we're given the input value for the point, which is 6. And the output value we calculated down here in part A, which was 9 pi. Remember? A of 6 is 9 pi. And our slope is going to be the elevation. See, this our slope of the function A is going to be the height. And so right here we have an elevation of 6. So on point slope form we have the equation y minus y sub 1, which is 9 pi, equals m sub t, which is 6, times x minus x sub 1, which is 6. So there we are. That's part C. Now part D. On what interval is a of x increasing? Justify. Well, a of x, I'll put D down here. D. A of x is increasing on, and we can just leave a blank. Let's leave a blank here, because a prime of x equals f of x is greater than 0. Okay? It's positive. And I'm going to just make a little chart here. F prime, F double prime. In this chart here in the F row, we put plus, minus, increasing, decreasing, and then up U, that's concave up, down U, concave down. And then F prime, we have put plus under the increasing arrow, minus under the decreasing arrow, and we put the increasing arrow under the concave up, decreasing arrow under concave down. And finally, in the F double prime, we put the plus under the increasing arrow for F prime and minus under the decreasing arrow for F prime. And so what we look for is where do we see f of x greater than 0? Well, we see it everywhere except 12. But 12 is kind of the function will be increasing. It's just sort of a horizontal asymptote there. So we will say increasing on 0, interval 0 to 18. And then you can separate it out to, you can go 0 to 12, 12 to 18. So that's the rationale. So we see f prime, I'm going to circle this, f prime is positive where that's increasing, what I circled there. Okay, now we have part E. Give the coordinates of any points of inflection on the graph of A, justify your answer. Well, what we look for is concavity. Where is the function up or down, right? And where the concavity changes. So here from 0 to 6, the function is increasing, but changes concavity at 6 and starts going downward. And then here at 12, we're changing from downward to upward. So we say that we have points of inflection at x equals 6, x equals 12, because f prime, or f, equals a prime of x okay, changes from increasing to decreasing or from decreasing to increasing. So So that's the whole problem worked out. It really shouldn't be too bad. Again, the sign chart is very helpful. The whole understanding, there's a pretty good chance on May 9th to see a problem similar to this. It just takes a little analysis. Calculator not needed. This is the non-calculator portion. Good luck, and as always, thanks for viewing.